LHS will be half 1/4 1 by 8 plus 1 by 2 to the power m. Then extra term, that is, we can put brackets also, 1 by 2 to the power m plus 1. Students or learners, you need not mention those steps, basic steps, hypothesis like this, inductive hypothesis, inductive step. No need of mentioning this, just you follow these steps. You see, sum, when k terms are there, sum is a within brackets r to the power k minus 1 by r minus 1. Now, by actual calculation, we have shown sum will be this one. Good morning viewers, good morning students, good morning those students who follow my classes. Welcome to btosacademy, welcome to my maths class. Today, in the first part, I shall work out few more sums on the topic principle of mathematical induction, or using principle of mathematical induction, simply mathematical induction. Then I shall move to next topic. Already I have written one sum. Let me work out step by step. This is to be proved by induction method. Already I have started in the earlier episode. Steps will be, first we take this statement as mathematical statement. Now the basic step for n equal to 1 LHS, that means n 1 means first term will be half, RHS 1 minus 1 by 2 to the power 1, that is equal to 1 minus half means half. Therefore P1 is true. Now inductive hypothesis. This part is called basic step. Already I discussed it earlier. Then inductive hypothesis. Let P M be true where m greater than 1, m is natural number. Therefore, half, 1/4, 1 by 8 plus dot dot plus 1 by, just we have to replace this n by m. Now we shall show by actual calculation P m plus 1 will be true. I am to use the right side. This is inductive step actually. This part is inductive step. For Pm plus 1. LHS will be half 1/4 1 by 8 plus 1 by 2 to the power m. Then extra term, that is, we can put brackets also, 1 by 2 to the power m plus 1. For Pm plus 1, left hand side is this equal this one. Now already we have assumed this is equal to this expression inside the first bracket is equal to 1 minus 2 to the power m. LHS is equal to 1 minus 1 by 2 to the power m plus this extra term. Now we simplify 1 minus, I take minus common, 1 by 2 to the power m minus 1 by 2 to the power m into 2. 1 minus, LCM is this one, 2 minus 1, that is equal to 1 minus 1 by 2 to the power m plus 1. Left hand side is equal to, now this will be represented by this RHS part if we replace m by m plus 1. In this case, RHS will be one minus 1 by 2 to the power m plus 1. Therefore, LHS is equal to RHS. Therefore, the conclusion of this part will be, therefore, P m plus 1 is true. We assumed Pm true and we have shown by actual calculation Pm plus 1 is true. Therefore, we can mention here when Pm is true. We can write also like this. Therefore, by the principle of mathematical induction, students may also write in short PMI. By the principle of mathematical induction, Pn is true. Therefore, final line, half 1/4 1 by 8 plus dot 1 by 2 to the power n is equal to 1 minus 1 by 2 to the power n, and mention n belongs to set of natural number. Hence proved. Next sum, 2 to the power 3n minus 1 is divisible by 7. Let Pn mathematical, this is mathematical statement. We start like this: Pn 2 to the power 3n minus 1 is divisible by 7. Now basic step. One thing, students or learners, you need not mention those steps, basic steps, hypothesis like this, inductive hypothesis, inductive step. No need of mentioning this, just you follow these steps. For n equal to 1, 2 to the power 3n minus 1 is equal to 2 cube minus 1. Putting n equal to 1, we get 8 minus 1, that is equal to 7. Naturally divisible by 7. We just mention divisible by 7. Therefore, P1 is true. Next, inductive hypothesis. Let 2 to the power 3n minus 1 be divisible by m, where m already we have shown this statement is true for n equal to 1. Now we are assuming, therefore this m is greater than 1 and natural number. That is why we have to mention here m greater than 1, m. Don't be confused. Sometimes I see students write m greater than equal to 1. We are assuming here. We first show the basic step. This is true for the minimum value of the variable. Here variable is n and minimum value is 1. After showing that, you need not write here m greater than equal to 1. Actually we are assuming, already we have shown this is true for the minimum value or least value. Then we assume that this is true for the values which is greater than 1, and that is of course natural number. That is why this is the correct way of representation. This is the inductive hypothesis. Now first part, this is inductive step. We are to, that is Pm 2 to the power 3n minus 1 is divisible by 7. This is the inductive step, inductive hypothesis. First, this is inductive hypothesis, and the first step is inductive step. Now, considering this is true, we shall show by actual calculation. Already I have mentioned Pm plus 1 will be true. For Pm plus 1, follow these steps carefully. From my experience, I have seen students express wrongly. That is why follow these steps carefully. This expression will be in that case 2 to the power 3. In place of m, it will be m plus 1 minus 1. Now I calculate the step like this: 2 to the power 3m plus 3 minus 1, and that is equal to 2 to the power 3m into 2 cube minus 1, that can be written as 2 to the power 3m. 2 cube means 8 into 8 can be written as 7 plus 1 minus 1. Note this step. I have written 2 cube means 8, 7 plus 1. Now why I have written the step? Keeping in mind this part, this is divisible by 7. Now this is equal to 7 into 2 to the power 3n plus 2 to the power 3n minus 1. Now you see, I have got a term of which 7 is a factor. Therefore, I can say easily this is divisible by 7. Now, the rest two terms, 2 to the power 3m minus 1. Now I put brackets here. Now I find this expression. Now, 7 into 2 to the power 3m is divisible by 7, and 2 to the power 3m minus 1 is divisible by 7, as mentioned, or you can write assumed, assumption. Earlier. Therefore, I can say this expression is divisible by 7. Therefore, 2 to the power 3 within brackets m plus 1 minus 1 is divisible by 7. We assumed this is divisible by, this one will be 7, not m, written wrongly. Now, taking or considering this assumption, we have shown by mathematical reasoning 2 to the power 3 within brackets m plus 1 minus 1 is divisible by 7. Therefore, Pm plus 1 is true. Therefore, P m plus 1 is true. As Pm is true, therefore by the principle I write in short, by the PMI, principle of mathematical induction, Pn is true. Therefore, finally we have to write this statement: 2 to the power 3n minus 1 is divisible by 7, where n is, remember, of set of natural numbers. So that alternatively, remember one thing, if it is asked you prove with the help of mathematical induction, you have to follow this method. Otherwise, if it is not mentioned, you can follow any method. This is the alternative way I am going to discuss. 2 to the power 3n minus 1 can be written as 2 cube whole to the power n minus 1. This is 8 to the power n minus 1. Now 8 can be written as 1 plus 7 whole to the power n minus 1. Now I use the binomial theorem. I think students of class 11, also class 12, have already learned binomial theorem, though I have not discussed in this class. I shall start later. Now, using binomial theorem, it will be 1 to the power n, that means 1 plus nc1 into 1 to the power n minus 1, means 1 into 7 to the power of 1 nc2 7 square plus dot 7 to the power n minus 1. I have used here binomial theorem. A plus x whole to the power n is equal to a to the power n plus nc1 a to the power n minus 1 into x to the power 1 plus nc2 a to the power n minus 2 into x square plus dot plus the last term ncn into x to the power n, and ncn is equal to 1. That is why 1 plus 7 whole to the power n will be this minus 1. Now these two 1s are cancelled. Therefore, finally what we get, 7 square plus dot 7 to the power n. Each term is containing 7. nc1 into 7 plus nc2 into 7 square plus nc3 7 cube plus dot plus 7 to the power n. Now 7 is the common factor. nc1 plus nc2 into 7 plus the last term will be 7 to the power n minus 1. And n is natural number, then n will start from 1, 2, 3 dot. Therefore, if n be 1, from it is clear, then it will be 7 to the power 0, that means 1. Therefore, 7 is common factor. Finally, we can write, let me write this. Therefore, the conclusive step is 2 to the power 3n minus 1 is divisible by 7. From this step it is clear that 7 is the factor, and you mention at the end step n is a natural number. Thus the sum is solved with the help of mathematical induction as well as using binomial theorem. Next I move to third sum. A plus AR plus AR square plus AR to the power n minus 1 is equal to A into R to the power n minus 1 by R minus 1. This is actually sum of first n numbers which are in GP, starting with the first term A and common ratio R. I have not discussed yet series sequence. Later on I shall discuss. You will find this, and this result or this formula can be proved easily with the help of mathematical induction. Sum, let Pn A plus AR plus AR square plus AR to the power n minus 1 is equal to A R to the power n minus 1 divided by R minus 1. Mathematical statement for n equal to 1, LHS will be the first term only A, RHS will be putting n equal to 1, that is A within brackets R minus 1 by R minus 1 equal to A. Since R minus 1 is there at the denominator, therefore it is quite natural R is not equal to 1. Also one thing, if R be 1, then each term will be A. That means no geometric progression exists. Therefore, it is clear R is not equal to 1. Now I find LHS, RHS equal. Therefore, P1 is true. Now, inductive hypothesis, let P, I write here Pk be true. That is AR square dot 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 A R to the power k minus 1 is equal to A within brackets R to the power k minus 1 divided by R minus 1. k is greater than 1, k belongs to set of natural. This is the inductive step. Now, assuming this, we shall prove p k plus 1 is true. For p k plus 1, left hand side will be ar square ar to the power k minus 1 plus ar to the power k minus 1. When k terms are there, power of r is k minus 1. Then for k plus 1 terms, we have to add this one. That means this power will be increased by 1. That is why ar to the power k. Now, sum of this one is this. I write here. Let me write there. Therefore, LHS is equal to A within brackets plus ar to the power k. Now we simplify. We find A is common. I take this one also as common, or take this as common factor. Then it will be r to the power k minus 1 plus r minus 1 is to be multiplied with r to the power k. That means r to the power k plus 1 minus r to the power k. We have simplified this. Now, these two terms are cancelled. What we get? A r to the power k plus 1 minus 1 by r minus 1. You see, sum, when k terms are there, sum is A within brackets r to the power k minus 1 by r minus 1. Now, by actual calculation, we have shown sum will be this one. Now, which is obtained by replacing k by k plus 1 in the RHS of, I take this as 1, RHS of 1. This is left hand side and this is right hand side. I have taken the whole as 1, relation 1. Therefore, this one will be obtained by, you see, from this one by replacing k by k plus 1. Therefore, the conclusion is p k plus 1 is true. Therefore, by PMI, Pn is true. Therefore, finally, A AR square plus A r to the power n minus 1 is equal to A r to the power n minus 1 by r minus 1, and n belongs to set of natural numbers you will find alternative proof also when you will read that topic, geometric progression. Now this one is proved with the help of mathematical induction.